Hi everyone, my name is Ankit Chopra and this is my project submission for the course of Managing Machine Learning Projects by Duke University. In this project, we're going to be taking the use case of predicting cloud capacity demand for a digital banking software product and services. The first part is to do an opportunity evaluation. Accurate cloud capacity demand planning is crucial for running efficient business, maximizing revenue, and preventing higher cost. In this section, we would like to discuss why is this a good machine learning problem to solve. The first point is, in a dynamic business scenario, the time is of the essence, and hence automation is required for faster results. The second point is, accurate prediction translates to cost optimizations. That means money saved. The third point here is, every product or service has different causal factors, and hence personalization for a specific product or service is required. Based on these three factors, we can conclude that this is a good machine learning to solve. Now let's look at this use case from the crisp DM business standing point of view. The problem here is that inaccurate demand planning leads to business loss in terms of revenue and customer retention. It matters because inavailability of a specific product or services can lead to loss of business opportunity. On the other hand, if there is over availability, this could mean higher cost for the company. In the current state, let's assume that the demand planning is based on heuristics and metrics like an average demand for last 3 months. In this scenario, we know that there are known gaps because it does not account for changes in customer base, usage patterns, or any market or product changes. A typical user of this demand planning machine learning model would be a director of planning, a finance manager, a product and engineering team who provisions and aggregates product or services. Let's define the success in this scenario. What we want to do is we want to quantify the expected business impact. This could mean metrics like per unit of over demand predicted translates into, say, X amount of dollars of cost. The other case would be per unit of under demand predicted translates into a loss of, say, Y dollars for profit. The constraints of the scenario would be that the predictions have to be delivered 24 hours in advance to make the right provisions. An output metric for this could be an additional revenue generated with accurate demand. An output metric for the ML model could be mean squared error or an error rate of predictions. In the third section, we can identify some of the factors that play an important role in this prediction model. There could be a bunch of important factors like number of active users and accounts, transactions that are being done per account, number of event or API calls that are happening, and what does the capacity per transaction per product type look like. Are there any specific factors like demand surges due to seasonality? For example, a holiday sale is going on and that's why it's causing a peak in demand. So these are some of the important factors. Solution validation plan. So in this section, what we're going to do is we would like to talk about a high level solution which we want to develop, and then how could we validate it before actually deploying it into production. So our goal here is to create a regression based prediction model which predicts capacity requirement for a specific customer during a specific day or based on important attributes. So we can first run a high level model on a shorter sample of data and compare whether it actually would deliver better outcomes than the current methodology or the heuristics based approach. Basically what we're trying to do is we're trying to test the data model before creating the pipeline. At a high level, these are the steps we'll follow. We'll gather the historical demand and data for each of the important attributes. We'll try and find the correlation between the output variable, which is the capacity required, and the input attributes, which could be individual factors. We would validate this correlation with an experienced team that the numbers which we are seeing in terms of correlation do they make sense. The third step would be to split the data into training and test data sets. After that, we can create a combination of regression models based on different inputs, and we can run the model on the test set and compare output metrics here for a final selection of prediction model. Now what we have done is we have created a bare bones prediction model and would like to compare the model performance with the existing methodology. Is it better than the heuristics based approach? So in this way, what we can do is we can validate our solution beforehand, before going and deploying it in production, before taking the humongous task of cleaning the data and all the other factors. ML system design. Let's talk about how could it look like. So we're going to evaluate it on three factors basically. Should we do a cloud-based? Should we do an offline learning or an online learning model? Should we do batch predictions or real-time predictions? So as we're predicting the demand at an aggregate level, we can assume connectivity for informational flow and the computations to be done on cloud and the end results delivered to target users. Hence, we can use the cloud model in this case. Offline learning. So model retraining can be done on a scheduled time frame, and hence it does not need to be online all the time, and we can use an offline learning model here in that case. Batch predictions. So we need to monitor drifts, and we can generate the predictions per day. So it does not have to be real time and updated on a very short frequency, and hence we can use batch predictions to in the ML system design. So what are the potential risks in production? The first one is the data drift, right? As we can understand, as the customer base grows and market conditions evolve, the model which is previously trained on the test data set might experience a data drift, and that's one of the key risks for production. The other one here is the concept drift. Over time, as the company introduces new products and features and usage patterns change, this can lead to the concept drift. Both of these drifts, the concept drift and the data drift, can be monitored, and model maintenance plan would come in very, very handy to keep the model up to date. This concludes my project submission for how we go about managing a machine learning project in a specific scenario of predicting cloud capacity demand for a banking product or service. Thank you very much for listening, and happy learning.